provide relevant information about the system, specific details are required. Without these details, it is impossible to give an adequate response. System information includes, but is not limited to, the purpose of the system, its components, its operating parameters, and any specific problems or questions you have about it. The more detailed the information, the better the answer. Firstly, consider the system's function. What is it designed to do? What are its inputs and outputs? Knowing the purpose of the system helps to understand its overall operation and identify relevant information. Secondly, identify the system's components. What are the key parts of the system, and how do they interact with each other? A detailed list of components, including model numbers and specifications, can be helpful. Thirdly, describe the system's operating parameters. What are the typical voltage, current, pressure, temperature, or other relevant parameters at which the system operates? Understanding these parameters can help to diagnose problems and identify potential issues. Fourthly, specify any specific problems or questions you have about the system. What are you trying to troubleshoot, understand, or improve? Clearly stating your objectives helps to focus the search for relevant information. Fifthly, consider the system's history. Has the system experienced any recent changes or modifications? Has it been operating normally in the past? Knowing the system's history can provide clues about potential problems or issues. Sixthly, provide any relevant documentation. Do you have access to manuals, schematics, diagrams, or other documentation that describes the system? These resources can be invaluable in understanding the system's operation and troubleshooting problems. Seventhly, consider the system's environment. Where is the system located, and what are the environmental conditions in which it operates? Factors such as temperature, humidity, and vibration can affect the system's performance. Eighthly, be as specific as possible. Avoid vague or general terms, and provide concrete details whenever possible. The more specific the information, the better the chances of finding a relevant and helpful answer. Ninthly, if possible, provide photographs or videos of the system. Visual aids can often help to identify components, understand the system's layout, and diagnose problems. Tenthly, be patient and persistent. Finding the right information can sometimes take time and effort. Keep searching, keep asking questions, and don't give up until you find the information you need. For electrical systems, important details include the voltage levels, wiring configurations, and protection devices used. For example, is it a 120 volt system, a 208 volt system, a 277 volt system, or 480 volt system? Is it a single-phase or three-phase system? What size are the circuit breakers or fuses protecting the circuits? For electronic systems, details about the components used, such as microcontrollers, sensors, and actuators, are important. What type of microcontroller is used? What are the specifications of the sensors? How are the actuators controlled? For mechanical systems, details about the moving parts, such as gears, bearings, and linkages, are important. What are the gear ratios? What type of bearings are used? How are the linkages connected? For hydraulic systems, details about the pumps, valves, and cylinders are important. What is the pump's flow rate and pressure rating? What type of valves are used? What are the cylinders' bore and stroke? For pneumatic systems, details about the compressors, valves, and actuators are important. What is the compressor's capacity and pressure rating? What type of valves are used? What are the actuators' force and speed? In summary, providing as much specific information as possible about the system in question is crucial to getting a helpful and accurate response. The more details that are provided, the better the chances of understanding the system and addressing any specific questions or concerns. Remember to include information about the system's function, components, operating parameters, history, documentation, environment, and any specific problems or questions. By providing this information, the chances of receiving a relevant and helpful answer will be greatly increased. Consider common issues. Is there an observed malfunction, like a motor that will not start, or a light fixture that is not illuminating? Explain any troubleshooting steps that have already been undertaken. Did you use a multimeter to measure voltage or current? What were the readings? Did you check for continuity? What were the results? For a motor that will not start, have you checked the power supply, the motor windings, and the overload protection? For a light fixture that is not illuminating, have you checked the bulb, the ballast, and the power supply? Be as detailed as possible in describing the problem. The more information you provide, the easier it will be to diagnose the issue and provide a solution. Consider the age of the system. Older systems may be more prone to certain types of problems due to wear and tear. If the system is very old, it may be difficult to find replacement parts. If the system is relatively new, it may be covered by a warranty. Knowing the age of the system can help to narrow down the possible causes of the problem. Consider the operating environment. Is the system located in a harsh environment, such as a factory or a construction site? Harsh environments can accelerate wear and tear and lead to premature failures. If the system is located in a harsh environment, it may be necessary to take extra precautions to protect it from damage. Consider the maintenance history. Has the system been properly maintained? Regular maintenance can help to prevent problems and extend the life of the system. If the system has not been properly maintained, it may be more prone to failures. Consider the system's design. Is the system designed for the intended application? Using a system for an application for which it was not designed can lead to problems. If the system is not designed for the intended application, it may be necessary to modify it or replace it with a more suitable system. Provide any error codes that are being displayed. Error codes can provide valuable clues about the nature of the problem. Look up the error codes in the system's documentation or online to get more information about the possible causes of the problem. Provide a clear and concise description of the problem. Avoid using jargon or technical terms that may not be understood by everyone. Use simple language to explain the problem in a way that is easy to understand. Providing all of these details will allow for a more thorough assessment of the situation and a more accurate and helpful response. Remember, the more information provided, the better the chance of receiving the assistance needed. Without sufficient information, only general advice can be offered, which may not be specific enough to address the actual problem. Please gather as much detail as possible and resubmit the query for a more targeted response. When dealing with electrical systems, safety is paramount. Always disconnect power before working on any electrical components. Use proper safety equipment, such as insulated gloves and safety glasses. If unsure about how to proceed, consult a qualified electrician. When working with electronic systems, be careful to avoid static discharge. Static discharge can damage sensitive electronic components. Use an anti-static wrist strap and work on a grounded surface. When working with mechanical systems, be careful to avoid getting your fingers caught in moving parts. Use proper safety guards and keep your hands away from moving parts. When working with hydraulic systems, be careful to avoid high-pressure leaks. High-pressure hydraulic fluid can cause serious injuries. Use proper safety equipment, such as safety glasses and gloves. When working with pneumatic systems, be careful to avoid high-pressure leaks. High-pressure air can cause serious injuries. Use proper safety equipment, such as safety glasses and gloves. Remember that all systems are different, and what works for one system may not work for another. Always consult the system's documentation before attempting any repairs or modifications. Providing details such as voltage levels, control system types, specific part numbers, and observed behaviors are key to understanding the question. If the system involves any form of automation, details about the programmable logic controller or other controlled devices are important. The manufacturer and model number of the PLC, the programming language used, and any specific error messages or alarms are crucial. Also, details about the sensors and actuators connected to the PLC are helpful. What types of sensors are used, and how are they wired to the PLC? What types of actuators are used, and how are they controlled by the PLC. If the system involves a human-machine interface, details about the HMI are important. The manufacturer and model number of the HMI, the type of display, and the functions that it performs are all relevant. Also, details about the communication protocols used between the PLC and the HMI are helpful. Is it Modbus, Ethernet, or some other protocol? Finally, if the system involves any form of networking, details about the network topology and protocols are important. Is it a star network, a ring network, or some other topology? What protocols are used for communication, such as TCP or IP? Providing this level of detail will allow for a much more accurate assessment of the situation and a more targeted response. Without this information, it is impossible to provide any meaningful assistance. Please gather as much detail as possible and resubmit the query.